கோயிலுக்கு வரதுல அங்க நீ டெஸ்ட் அப்ப பண்ணிட்டியா?
எக்ஸ்கியூஸ் மீ சார், நீங்க மியூட்ல இருக்கீங்க சார்.
Sir, unable to hear, sir.
Yeah, am I audible now? Hello?
Yes.
Yeah.
Yes, sir. Yes, sir.
Yeah, okay. See, what is a macro state? Macro state is a specification of number of particles in each energy level correspond to the particle. Okay, what is meant by that? See here, the particles that I mean, okay, are maybe atoms or maybe molecules, or it can be molecular ions. Okay. Hello, everyone, please mute your mic. Now, see, we have a container. Okay, just for understanding macro state, I have taken a container here which consists of 5 particles. Okay, see, I repeat, the particles that I mean here may be atoms or maybe molecules. Hello? Somebody is not muting.
Yes, sir.
Yes, present, sir.
Please mute your mic. Hello?
Hello.
Everyone, please mute your mic. Right. This Galaxy J2 mobile. I don't know who is that. Okay. Yeah. Now, suppose assume that I have a particle. It can be atom or molecule, or it can even be an ion. Now listen. Suppose assume that it is a molecule, right? Each and every particles here are molecules. For molecules, we have rotational levels, you know very well, right? Molecules have rotational levels, molecules have vibrational levels, molecules may have electronic levels, right? So you take any one of the energy level, okay? Because it depends upon which property you are going to determine. We are going to calculate. So based on that, you have to choose the correct energy levels. Right now, for the molecule, for the given molecule, using quantum mechanics, okay, we have to calculate the quantized energy levels. Quantized energy levels. Assume that these are all energy levels associated with the molecule. Okay, I repeat, these levels may be rotational levels, or maybe vibrational levels, or maybe electronic levels, right? So whatever it may be, right? We have to choose the energy levels depending upon what property that you are going to measure. Okay, so keep this in your mind. These energy levels of the molecules can be obtained using quantum mechanics. Okay, yeah. Now see in the container we have only 5 particles. Let us assume for this molecule, assume that we have only 3 levels. Just imagine like that. Okay, for the molecule, right? We have only 3 levels. I have told you these levels, energy levels, may be rotational levels, or maybe vibrational levels, or maybe electronic levels, whatever it may be. Right now, what I'm just for understanding purpose, what I'm saying that the molecule has only 3 energy levels, and I'm going to distribute 5 particles. The container has 5 particles, and all are same molecules. Okay, all are same molecules. That means these energy levels are same for all the molecules. That's the meaning. Okay, suppose if the molecules are oxygen molecule, right? All are oxygen molecules, and these energy levels are corresponds to the oxygen molecules. Now we have to distribute these 5 molecules. Suppose assume that there is a situation where 3 molecules present in the ground level, okay, E0 level, and 1 molecule present in E1 level, and another molecule present in E2 level. Just imagine the molecules are distributed like this. Now, what is a macro state? What is meant by macro state? Listen, macro state is a specification of number of particles in each level. See, in the ground level, how many particles are there?
3 particles.
3 particles. Then the next level has 1 particle. Then the next level has 1 particle. So 3, 1, 1. This is actually a specification, right? We are specifying some numbers, right? So this specification of number of particles in each energy levels, right, of a substance is what we call as a macro state. This is what we call as a macro state. This is one macro state, right? See, suppose I have 3 levels. In that, say for example, I have 3 particles here and 2 particles here. Now, what is the specification? Can anyone tell me what is the specification here?
320.
3,
3, 2,
2, 0.
0.
3, 2, 0. Listen, now, are the 2 specifications are same?
No, sir.
They are not same. The first one on the 3, 1, 1 irukku. Second one 3, 2, 0 irukku. So they are not same. That means these 2 specifications are different specifications, or we can say in the other way, these 2 are different macro states. Okay, so what is a macro state? Macro state is a specification of number of particles in each and every energy level of a system at a particular instant of time. Okay, or particular instant of time, how molecules are distributed in different energy levels, right? Now, this is what we call as macro state, right? Now, listen. So now you know what is meant by macro state. Okay, now I'll give a distribution. Can anyone tell me what is the in this for this? So I have 4 particles here, I have 2 particles here, I have 1 particle here, right? Yeah. Can anyone tell me what is the occupation index for this? Occupation index means
4, 0,
number of particles. Yes. 4,
2, 0, 1.
2, 0, 1. Right? It is also called occupation index or specification of number of particles. Everyone is saying this is what we call as a macro state. This is a macro state. Listen, for a system, see this system consists of totally 7 molecules, right? For a system, don't think that only one macro state will exist. No. For a system, there may be many macro states possible. Okay. See, what I'm trying to say is what is meant by a macro state? That's all. Okay, this is one possible macro state for the system. Now, let me go to the next one called microstate. Do you have any doubt in this? In macrostate? See, macrostate under how to specify, or macrostate is nothing but specification of number of particles in each energy level. Right? Listen, at a particular time, you'll have some distribution. Right? If the time changes, then some molecule may go to higher level, some molecule may come down. So the macro state will change. Okay, at a particular instant of time, right, you will have one particular macro state. That's the meaning. Yeah, any doubt? Any doubt in this?
No, sir.
Okay, now let me come to the next one, second term called microstate. See, if you have any doubt, please unmute your mic and ask me the question, okay? Whatever doubt comes, please unmute. Because this subject is very easy, but we should try to understand some of the meanings, okay? Now, what is meant by a microstate? Listen, so we have energy levels, right? Assume that I have, say for example, I have 4 levels, right? And assume that I have only 2 particles, right? My container has only 2 particles. And what I'm going to say that, suppose if the 2 particles are distinguishable, if these 2 particles are distinguishable, right? Distinguishable means we can differentiate one particle from other particle at any instant of time. We can distinguish one particle from the other particle at any instant of time. So I'll call this particle, I'll represent this particle as A and this particle as B. See, at any instant of time, I can very well say that, okay, where is particle A and where is particle B in the container. Okay, so we can call them as distinguishable particles. You know very well, then suppose if you take a crystal, try to understand this, what is meant by distinguishable particles. They are distinguishable particles. See, in a crystal, see, we have lattice, we have crystal lattice, right? Assume that I have a particle here and I have another particle here, right? Another particle here. Now listen, I'll take this as x-axis and this as y-axis. Now, in the crystal, I can say very well that what is the position of this particle. Okay, this particle may present at some position, some x value, may have some x value, may have some y value. Okay, I know the position of the particle. Listen, since it is a crystal, the particle cannot move. Only equilibrium vibration will be there. Equilibrium vibration will be there, but equilibrium vibration is very small, negligibly small. So we can say that the position of the particle is not changing. So at any instant of time, I can say that the particle A is here and particle B is here and particle C is here because the particles are not moving, right? So listen, see, this is very important. I'm not saying that these particles are different particles. See, suppose if you take say iodine crystal, right? Every lattice position consists of iodine molecule only. Every lattice position consists of iodine molecule. But we can distinguish one iodine molecule from another iodine molecule using their position, because in the crystalline state, they cannot move. So I can very easily identify where is molecule A, where is molecule B. Are you able to understand? So that's the meaning for distinguishable. Distinguishable means you don't think that one molecule is iodine molecule, another molecule is chlorine molecule or methane molecule. No, it's not like that. All molecules are same molecules only, but we can distinguish them at any instant of time. This is possible. Okay, this is possible in crystals. In crystals, the molecules cannot move, so their positions are fixed. Therefore, I can distinguish one molecule from another molecule using the Cartesian coordinates. Sir, are you able to follow?
Yes, sir.
Yeah. So the word distinguishable particles is very well applicable for solid substances or crystalline substances. If you take a gas, suppose I'll take oxygen gas in a container, which consists of many oxygen molecules. See, the oxygen molecules are moving randomly with a very high velocity. So it is very difficult to distinguish one oxygen molecule from another oxygen molecule in the gaseous state. Am I right? Sir, are you able to follow? If you take a gas,
Yes, sir. Yes, sir.
yeah, in gaseous state, molecules are moving randomly, randomly. So we cannot distinguish one molecule from another molecule, one oxygen molecule from another oxygen. We cannot distinguish. We call these particles as indistinguishable particles, right? Yeah. So what is meant by distinguishable particles? What is meant by indistinguishable particles? Okay. Distinguishable na இப்படி மீனிங் எடுத்துக்காதீங்க. ஒரு molecule oxygen, இன்னொரு molecule nitrogen. No. அப்படி மீனிங் கிடையாது. All molecules are same molecules only, but we can distinguish them at any instant of time. Okay. So I have given one nice example in the crystal. I suppose you take iodine crystal. In iodine crystal, right? Iodine molecules are present in the lattice position, right? We can distinguish one iodine molecule from another iodine molecule at any instant of time, because in the crystal they cannot move. So we can easily locate the position of one molecule from another molecule. So we can easily distinguish them. Are you able to follow? Now, listen, what I'm trying to say here is, now we have a container, right? That container has only two particles, A and B. Okay, listen, A and B means they are not different particles, they are same particle. What I'm trying to say that we can distinguish them. They are distinguishable particle. Now, I'll place particle A here, I'll observe pannunga, and I'll place a particle say B here, Can you tell me what is the macro state correspond to this arrangement? Can you tell me occupation index? ஏன்றது ஒரு பார்ட்டிகிள், பின்றது ஒரு பார்ட்டிகிள். நான் முன்னாடி டாட் மாதிரி வரைஞ்சேன், இப்போ ஏ பி ரெப்ரசென்ட் பண்றேன், ஏன்னா they are distinguishable. அதுக்காக. Can anyone tell me what's the occupation? Yes.
101.
1010. Am I right? So this is the macro state for this arrangement. In the arrangement kind of macro state is that. Now listen, see this carefully. Now where is particle A? Where is particle A? In the ground level, right? Now listen, now what I'm going to do, see, I'll take the same energy levels. Now I'll place particle B here and particle A here. Can you tell me what is the macro state for this? What is the macro state for this? Same macro state, correct? Same macro state. Now listen, so this macro state can be obtained. You can attain this macro state in two different ways. This is one way, this is another way. Am I right? In the macro state, ரெண்டு வகையில நீங்க attain பண்ணலாம். Okay, keeping particle A down, அது ஒரு arrangement. Keeping particle B down, this is another arrangement. So are you able to follow this? See what I'm saying? This macro state can be obtained in two different ways. Okay, the different ways, okay, each and unique way of attaining a particular macro state is called a microstate. So this is one microstate, this is another microstate. Sir, understand பண்ணிக்க முடியுதா?
Yes, sir.
Yeah. See, அதாவது மேக்ரோ ஸ்டேட் ரெண்டுத்துக்கும் மேக்ரோ ஸ்டேட் சேம் தான். பட் நான் என்ன கொஸ்டின் கேட்குறேன், ஆர் த டூ எக்ஸாக்ட்லி சேம்? இந்த ரெண்டு அரேஞ்ச்மெண்ட் ஒரே மாதிரி இருக்கா?
No, sir.
நோ. ஏன் ஒரு அரேஞ்ச்மெண்ட்ல பார்ட்டிகல் ஏ கீழே இருக்கு, பி மேல இருக்கு. இன்னொரு அரேஞ்ச்மெண்ட்ல பி கீழே இருக்கு, ஏ மேல இருக்கு இல்லையா? தே ஆர் டிஃபரெண்ட் அரேஞ்ச்மெண்ட், டெஃபினெட்லி டிஃபரெண்ட் அரேஞ்ச்மெண்ட். ஸோ த டிஃபரெண்ட் வேஸ் or we can say each way of getting a particular macro state, right, is called a microstate. Right? I'll write here, next page. So what is a microstate? What is a microstate? The other name for microstate is complexion. Some old book, if you see, instead of the word microstate, they'll use the word complexion, but both are having same meaning. Okay. Now, what is a microstate? What is meant by that? See, each unique way of attaining a particular macro state. Each unique way of attaining a particular macro state. Macro state is what we called as microstate. இதுக்கு பேர் தான் microstate. Each way is called a microstate. Right? See, this is one microstate, keeping A down, B up. This is one microstate. This is another microstate, keeping B down, A up. Another microstate for the macrostate 1, 0, 1, 0. Okay, for both these arrangement, the macrostate is same. Okay, macrostate is same, but there are two ways of getting this macrostate, and each unique way is called a microstate. So how many microstates are possible for this macrostate? For this macrostate, how many microstates are possible?
2.
2 microstates are possible. Right? Now listen, I'll give a shortcut formula to find the number of microstates. Okay, number of microstates, W. Listen, it is also called statistical weight. இதுக்கு இன்னொரு பேரு statistical weight ன்னு சொல்லுவோம். What is the meaning? The meaning is number of microstates associated with the given macrostate. Okay, for a given macrostate, how many microstates are available? That is called statistical weight. Right? What is the formula? If it is a distinguishable particle, if the particles are distinguishable, then you can use this formula, right? The formula is W is equal to n factorial divided by pi into ni factorial. What is this? Capital N represent total number of particle. Okay, total number of particle, capital N. Capital N represent total number of particles present in the substance. Please mute your mic. Excuse me. And what is Ni? Ni is nothing but number of particles in each level. Okay, in the ith level, I can say it like that. Number of particles in ith level. That is Ni. Okay, and what is this pi represent? Pi means multiplication. Okay, pi means multiplication. If you use this formula, you can get the number of microstate directly. See, I'll just use the formula here for this system. See, for this system, totally how many particles are there here? How many particles are there? Totally, we have 2 particles. So 2 factorial divided by. Now, in the ground level, we have 1 particle. So 1 factorial. Next level, no particle, 0 factorial. Next level, 1 particle, 1 factorial. And the last highest level, no particle, 0 factorial. Okay. Now, what is 2 factorial? 2 factorial means 2 into 1. You know very well 1 factorial is 1, 0 factorial also 1. See, 0 factorial and 1 factorial both are equal to 1. Very, very important. Okay, so 1 factorial is 1, 0 factorial is also 1. So in the denominator we have 1, 1 into 1 into 1 is 1. Numerator we have 2 into 1, 2. So the answer is 2. So how many microstate are there?
2.
2 microstate. Okay, now in the diagram put kamchom. Right now using formula I'm giving you the answer directly. Right, this formula is applicable only for distinguishable particles. Right? Yeah. Do you have any doubt in this? Hello?
No, sir.
Yeah. So this is what we call as microstate or complexion. Now, so now you know what is meant by macrostate and what is meant by microstate. Okay. Now what I'm going to do is that what is meant by thermodynamic probability. Thermodynamic probability. Take down. What is meant by thermodynamic probability? We represent thermodynamic probability. See, somebody is not unmuting the mic. Sorry, muting the mic. Please mute your mic. Okay, thank you. Now, see, thermodynamic probability is represented by the symbol W or by the symbol omega. Okay, you can see these two symbols. It is also called statistical weight. I have told you thermodynamic probability is also called statistical weight. Now, what is thermodynamic probability? Thermodynamic probability, what is meant by that? It is nothing but number of microstates it is nothing but number of microstates associated with a given macrostate. Right. Number of microstates associated with a given macro state. This is what we call as thermodynamic probability. So what is thermodynamic probability? Thermodynamic probability is nothing but number of microstates associated with a given macro states. Okay, so for a given macro state, how many microstates are possible? That is nothing but thermodynamic probability, which is usually represented by the symbol W. Now listen, you know very well in 10th standard or 9th standard, you might have learnt about mathematical probability. Mathematical probability, right? நீங்க லோவர் கிளாஸ்ல இந்த காயின் டாஸ் விடுறது, அப்புறம் டைஸ் உருட்டுறது, இந்த மாதிரி கேம்ஸ் யூஸ் பண்ணி ப்ராபபிலிட்டி படிச்சிருப்பீங்க, which is what we call as mathematical probability, which is usually represented by the symbol P. Listen, mathematical probability for which the lowest possible value is 0 and the highest possible value is 1. For mathematical probability, lowest possible value is 0, highest possible value is 1. But for thermodynamic probability, TP, for thermodynamic probability, okay, which is represented as W, for this, the lowest possible value is 1 and highest possible value can be anything, right? It can take any value, right, above that. Okay, it can take any value. The lowest value is 1. Highest value can be even 5,000, 10,000, 20,000, etc., etc. Okay, so this is the main difference between mathematical probability and thermodynamic probability. Okay, thermodynamic probability உடைய least value 1. என்ன அர்த்தம் அப்படின்னா கவனிங்க, suppose if all the molecules present in the ground state வச்சுக்கோங்களேன், if all molecule present in the ground state, then you will get W as 1. Sir, understand பண்ணிக்க முடியுதா?
Okay, sir.
W எப்போ 1 வரும்? W ன்றது number of microstate. Number of microstate எப்போ 1 வரும்? If all the molecules
present in ground level.
அவ்வளவுதான். If all molecule present in ground level, then number of microstate or thermodynamic probability or statistical weight எல்லாம் ஒரே மீனிங் தான். அது 1 ன்னு வந்துரும். Now I will ask the question in the other way. At listen, how to get or how to attain this this state? எல்லா மாலிக்யூலும் கிரவுண்ட் ஸ்டேட்டுக்கு வரணும். இது எப்படி அட்டைன் பண்ணுவீங்க? எப்ப மாலிக்யூல் ஹையர் லெவலுக்கு போகும்?
எக்ஸைட்டேஷன்.
அது எப்ப நடக்கும்? எஸ் யூ ஆர் ரைட். சொல்லுங்க. எப்போ எனர்ஜி கொடுத்தா ஹையர் லெவலுக்கு போகும் இல்லையா? ஹீட் கொடுத்தீங்கன்னா, ஹீட் சப்ளை பண்ணா ஹையர் லெவலுக்கு போகும். ஓகே, நான் இப்போ என்ன கேட்குறேன், எல்லா மாலிக்யூல் கிரவுண்ட் லெவலுக்கு வரணும். அப்போ என்ன பண்ணணும்? ஃப்ரீஸ் பண்ணணும். அப்படின்னா ஃப்ரீஸ் என்ன அர்த்தம்? என்ன பண்ணணும்? எப்படி ஃப்ரீஸ் பண்ணுவீங்க? என்ன பண்ணா ஃப்ரீஸ் ஆகும்?
டெம்பரேச்சர் டிக்ரீஸ் பண்ணணும்.
அவ்வளவுதான். டெம்பரேச்சரை டிக்ரீஸ் பண்ணணும். எந்த டெம்பரேச்சர் வந்து இது வரும் சொல்லுங்க? எந்த டெம்பரேச்சர் யூசுவலா?
ஃப்ரீசிங் பாயிண்ட்.
இல்ல இல்ல, உங்களுக்கு தெரியலையா? ஃப்ரீசிங் பாயிண்ட்ல கூட வைப்ரேஷன் இருந்துட்டே இருக்கும்.
0 Kelvin sir.
Towards 0 Kelvin. When temperature approaches 0 Kelvin. When temperature approaches 0 Kelvin, then all molecules will go down. All molecules என்ன சொல்றாங்க? ரொட்டேஷன் லெவல் மட்டும் இல்ல, வைப்ரேஷன் லெவல், எலக்ட்ரானிக் லெவல், எல்லா லெவல்லையும் molecule will come down and molecule will occupy only the ground level. When molecule occupies only the ground level, when all molecule occupies only the ground level, then the value of W is 1. Okay? Sir, எல்லாருக்கும் புரிஞ்சுதா?
Okay, sir.
Yeah. So keep this in your mind. This is very, very important. Okay. So now you know what is macro state, what is micro state, and what is meant by thermodynamic probability. Okay. யாருக்காவது ஏதாவது டிஃபிகல்ட் இருக்கா சார்? அண்டர்ஸ்டாண்ட் பண்ணிக்க முடியாம இருக்கா? மேக்ரோ ஸ்டேட்ன்றது என்னன்னா, ஒவ்வொரு லெவல்லையும் எவ்வளவு பார்ட்டிகிள் இருக்கு நீங்க ஸ்பெசிஃபை பண்ணீங்கன்னா அது மேக்ரோ ஸ்டேட். ஓகே, எல்லாரும் மியூட் பண்ணுங்க சார், கொஞ்சம் மியூட் பண்ணுங்க. யா, ஒவ்வொரு லெவல்லையும் எவ்வளவு பார்ட்டிகிள் இருக்குன்னு நீங்க ஸ்பெசிஃபை பண்ணீங்கன்னா அந்த ஸ்பெசிஃபிகேஷனுக்கு பேர் தான் மேக்ரோ ஸ்டேட். அடுத்து மைக்ரோ ஸ்டேட் என்னன்னா, அந்த மேக்ரோ ஸ்டேட்டை எப்படிலாம் என்னென்ன வேஸ்ல அட்டைன் பண்ணலாம். Okay, you can attain the macro state in different manner. Each way of attaining the macro state is called a micro state. Then what is meant by thermodynamic probability? ஒரு மேக்ரோ ஸ்டேட்டை அட்டைன் பண்றதுக்கு எத்தனை மைக்ரோ ஸ்டேட் பாசிபிள், ஆர் ஒரு மேக்ரோ ஸ்டேட்டுக்கு எத்தனை மைக்ரோ ஸ்டேட் பாசிபிள், அதுதான் thermodynamic probability. ஓகேவா? Then I'll introduce the last term, then I stop here. Listen, the last term is this. What is meant by most probable macro state? Most probable macro state. Right? Also called equilibrium distribution. இதுக்கு இன்னொரு பேரு ஈக்குலிபிரியம் டிஸ்ட்ரிபியூஷன் அப்படின்னு சொல்லுவாங்க. எல்லாம் ஒண்ணுதான். எஸ், what is meant by most probable macro state? I have told you, suppose you take a system containing a gas. I have number of molecules here. நல்லா அப்சர்வ் பண்ணுங்க. For this system, many macro states possible. Macro state 1, macro state 2, macro state 3. Assume that, just for understanding purpose, assume that we have only 3 macro state possible for the system. நான் அதுக்கு கொஞ்சம் டீட்டெயிலாக வரேன், நிறைய பேச போகிறோம். ஒரு சிஸ்டம் இருக்கு, அந்த சிஸ்டம்க்கு assume that we have 3 macro state possible. Now each macro state has a number of micro state W1. For this macro state you have some number of micro state W2. For this macro state we have some number of micro state W3. Now among these, which one is the highest number you see? Suppose W2 is greater than W1 and W2, W3. W1, W3 விட W2 வந்து high னு வச்சுக்கோங்களேன். அப்போ this macro state M2 is called the most probable macro state. Now, can anyone tell me what is most probable macro state? நான் சொன்ன இந்த இன்ஃபர்மேஷன் சொல்லுங்க பார்க்கலாம். ஹலோ,
highest microstate value, sir.
அவ்வளோதான். எந்த மேக்ரோ ஸ்டேட்டுக்கு ஹையஸ்ட் நம்பர் ஆஃப் மைக்ரோ ஸ்டேட் வருதோ அதுதான் மோஸ்ட் ப்ராபபிள் மேக்ரோ ஸ்டேட். ஸோ அப்போ ஒரு 2-3 மேக்ரோ ஸ்டேட் கொடுத்துட்டு எது மோஸ்ட் ப்ராபபிள் மேக்ரோ ஸ்டேட் என்ன பண்ணணும்? ஒரு 2-3 மேக்ரோ ஸ்டேட் கொடுக்குறாங்க, மேக்ரோ ஸ்டேட்டு எது மோஸ்ட் ப்ராபபிள் மேக்ரோ ஸ்டேட் கேட்டால் என்ன பண்ணுவீங்க? ஒன்றுக்கும்
மைக்ரோ ஸ்டேட் ஃபைண்ட் அவுட் பண்ணு சார்.
அவ்வளோதான். ஒன்றுத்துக்கு மைக்ரோ ஸ்டேட் கண்டுபிடிக்கணும். கண்டுபிடிச்சிட்டு அதில் எதுக்கு எந்த மேக்ரோ ஸ்டேட்டுக்கு மேக்ஸிமம் நம்பர் ஆஃப் மைக்ரோ ஸ்டேட் வருதோ அதுதான் மோஸ்ட் ப்ராபபிள் மேக்ரோ ஸ்டேட். ஓகே, யா, ரைட். ஐ ஸ்டாப் ஹியர். வில் கண்டினியூ இன் த நெக்ஸ்ட் கிளாஸ். ஓகே சார், இருக்கா டவுட் இருக்கா இதில்?
No sir. Okay, no sir.
Right sir. Okay, stop here. I will continue next class. This week probably we may have one more class. நடுவுல ஏதாவது கிளாஸ் இருக்கும், நான் உங்களுக்கு இன்ஃபார்ம் பண்றேன் முன்னாடி. ரைட்?
Okay, thank you, sir. Thank you, sir.